AP Cram, Calculus AB, Free Response, Exam Review, Question 19, Fundamental Theorem of Calculus. All right, so the figure shows the graph of f prime, that's the first derivative of a twice differentiable function f on the interval including the endpoints -3 and 4, okay? The graph of f prime has horizontal tangents at x is equivalent to -1, x is equivalent to 1, and x is equivalent to 3. The areas of the regions bounded by the x-axis and the graph of f prime on the intervals between and including the endpoints -2 and 1 and 1 and 4 are 9 and 12 respectively. Given that f, not f prime, f of 1 is equivalent to 3, write an expression for f of x that involves an integral, and then find f of 4 and f of -2, okay? So our task is threefold. Write an expression for f of x that involves the fact that f of 1 is 3 and an integral, then use this expression to find f of 4 and f of -2, okay? This is a little bit more involved and the calculus gets a little hairy on this one, but it's not that bad. So I'll give you a moment to think. All right, so our task again is threefold. We have to write a general expression for f of x involving the fact that f of 1 is 3. All right, and in order to do this, we're going to apply the fundamental theorem of calculus. And the fundamental theorem of calculus tells us this. I'll try to make it as simple as possible because breaking down this theorem is really hairy, so it's just best to do an example. If we're given a continuous function, here we're given not just any old function, we're given the first derivative or f prime of a function. But a derivative is still a function in and of itself. And there's a caveat in the fundamental theorem of calculus that says if the function is continuous, here we see the function is continuous on the interval for -3, 4, and there are no holes in the function, then doing something like this. Taking the integral of f prime of x is just simply going to undo differentiation and give us f of x, okay? So basically, the fundamental theorem of calculus is that long explanation that kind of connects the worlds of differentiating and integrating. One is so if we integrate a specific function, we're going to get the antiderivative. And if we, differentiate, we're going to get that function back. If we differentiate that antiderivative, we'll get the function back. So I don't know if you can see this, but what this integrating just basically undoes differentiation. Sorry for the time lag in my drawing. All right, so it undoes this and it just gives you f of x. And in this case, it has to be from a constant to some value of x, any value of x. And the constant that we have already, our initial condition that we're given, is 1. We know that f of 1 is going to give us 3, so we can represent that as an integral, okay? So f of x is equal to our initial condition, 3, because we're adding the integral from 1 to x. And this x can be any x along the interval shown here, okay? And it's going to be the integral of f prime, which is our graph here. I meant to say dx, but I wrote dt. Sorry about that. This should be an x. All right. Now we have to use this expression. So this answers this portion of the question. Now we have to find f of 4. So f of 4 is going to be really easy. F of 4 is equivalent to our initial condition, 3, plus the integral from 1, because that's where we left off. We got our answer for f of 1, so now we have to find the answer up to 4. And so from 1 to 4 is going to be the integral of f prime of x dx. Ignore the t's, they should be x's. And we don't have to do any math for this because we're already told that the area under the curve, which is the same thing as the integral of f prime between 1 and 4, is 9. So we can just incorporate that into our solution. So, it's 12, negative 12, okay? So the yeah, that's about right. And the reason why it's negative 12 is because it's like the area is in quadrant 4. If it were in quadrant 1, it would be a positive, but this whole entire region right here lies in quadrant 4. So the absolute value of the area is 12, but the numerical value, including the signs, is going to be negative 12 for those of you who are a little thrown off. Okay, so we know that 3 plus 12 is going to give us negative 9. So f of 4 yields a negative 9. Okay? All right. And this is after you incorporate the fact that f of 1 is equivalent to 3. All right? So that takes care of this. Now we have to find f of negative 2. But we're told that the area between 1 and negative 2 is 9. So between here and here is 9. It's going to be a negative 9 when we incorporate the signs. So we can use this information, but we're going to have to sort of flip things around. So f of negative 2 is equivalent to 3 plus the integral from 1 to negative 2. And we're not starting at 0, we're starting at 1 because we already know our answer for 1. So we just, skip a beat to go from 1 to negative 2. If we were starting from here, the integral would be from 0 to negative 2, but we're actually starting from out here. So negative 2 is a smaller number than negative 1. And usually when we're using the fundamental theorem of calculus, we start from a lower number to go to a higher number. But since we've done things here in reverse, all we have to do is flip the integral, and flipping the integral is going to negate the integral, changing this plus sign to a minus sign. So it's going to become 3 minus the integral from negative 2 to 1 of f prime of t dt, which, again, this t should be an x, because we're not, I'm thinking that we're differentiating with respect to time. Time is usually along the x-axis, but there's no time in this particular question. All right, so now we could just go ahead and plug in our answers. It's going to be 3 minus a negative 9, okay? And that's going to give us an answer of 12. All right? So we found we found a general integral expression starting at the value of 1. And we also incorporated the initial condition, which is